All right, so I'll okay, so I'll start with this once again. So we do have a control plane and a data plane here in switching. So the switching system, the task of the switching system is to basically find out that, this is a call that has arrived, or this is a possible call from a particular source or end system, and therefore it needs to be connected to a particular central office or particular node in the background network. So what should be that network, right? So that decision is done at this switching system with the help of the switch hardware and the switch controller. Okay, so that is why you have a connection between the control plane and the data plane here. Okay, so okay, so what are the challenges that we have when we are trying to do switching here? Okay, so one is any user can call any other user. So we actually do not have direct lines from an end user to another end user. So we do have to find that how to connect this one end user's connection to another end user, right? So why? Because we are of course using circuit switching here. All right. So yes, so this is the part of switching that we have. And I've already mentioned that switching happens in two parts. One is, you have a switch and you have a switch controller. That means you have a switch hardware and a switch controller. So in this course, we are actually also going to look at how switch hardware is basically, or how switch hardware looks like, and how a switch controller works. Okay, so we are going to take a look at these things too. Now, yes, as I was telling, so switching, what does a switch basically do? Okay, the task of the switch is what? It has to transfer data from one input to another output. Okay, now there can be many calls made. So how this hardware should look like? So there can be any call from any node to any other node, right? So how should this hardware look like? How this circuitry should look like in between, so that it is the most efficient way of connecting one node to another node. That means you do have a path even between the circuit, so that you can actually allow more and more number of connections to be connected at the same time. Okay, or switched at the same time. So this is one typical way of connecting, or it is the basically the circuitry inside the switch. One typical way, you can see the diagram here. Okay, it looks like a grid network. So we will see in details in the next modules as to what it is called and how it looks like, etc. Okay, but for now, we will try to know what are the features that are required for a switch. Okay, so since we need many inputs and many outputs, we need many ports, and we need very high speeds for that. Okay, so unless these switch controllers are very high speed, you cannot send more and more data, right, at the same time, or you cannot make more and more connections at the same time. So if the delay happens there itself, of course there is going to be more delay when you are trying to make a long distance communication here. Okay, so this hardware needs to work as fast as possible. Okay, so as I was told that nobody knows about space division, so I will take this part, that is what is space division and all, when I am actually talking about the switch architecture with space division multiplexing. Okay, so this is going to be there in the next class. Now, what if your inputs are multiplexed? Then how do you work? Okay, now we have already studied, right, in telephone networks that we can use digital multiplexing. We use digital multiplexing, and if we use digital multiplexing, that means you have your input, if you have n inputs, your output should be n times faster than that. Okay, now what will happen if you have such kind of a scenario here at a switch? So then you have to make a decision that which input port will you be choosing for transmission at which point of time. So that is why we need a schedule at this point. Okay, so when your inputs are multiplexed, we need a schedule to first understand that which one should be given the permission to transmit their data first. Okay, so these are the requirements that we have for a switch. Now let us see how a switch basically works. So this is just the insights of what we have. So it's like this, you have the inputs here, you have buffers where the data is actually waiting until it gets a chance to be basically transmitted to the output port, corresponding output port. Okay, so this has been called as a server here. Let us not call it as a server for now. So you have buffers, you have input ports, you have output ports. In between, you have the switch fabric or a circuitry in between. Okay, this circuitry is responsible for making a path between the input and the output port and transferring that data. Okay, so this is how this entire switch fabric or switch circuit will look like. And yes, so we can have different ways of switching. It can be time division, space division, etc. We will see in the next class with details how it works out. And as I told you that we do need a schedule in case of when we have multiplexed data coming in. And when we have larger switches, we try to combine different types of switching elements. It can be space or time division switching elements. So I think I will not go any further in this class today because I think next, oh no, this can be done. Just these two slides I will go further. Okay, so all right, so this is the last module. Okay, signaling. Okay, so what we know that this switching system has a switch and a switch controller, which basically tries to find out that how to send the data or which way to send the data. Okay, but it does not touch voice samples. Okay, the switch controller does not touch voice samples because it is basically going to manage, it is in the control plane. All right, so the switch controller, so what it does basically, it manages the network. What does it do? Call routing, that is collects a dial string and forwards the call, rings the bell at the receiver side to let the receiver know that there is a possible call, responsible for billing and directory lookup. Okay, for directory lookup is for emergency calls. Okay, so that is the task that is done here. And what is the other task of the switch controller? That is, it keeps track of state of every endpoint that is connected to it. There can be endpoints which become disconnected due to some issues with, either some natural issues or some issues with the system itself. If that system is not connected at all, then if any other source is making a call, then you cannot connect to that point, right? So the switch controller needs to have the information that whether an endpoint is actually working or not working. Okay, so sometimes if somebody's phone is dead, when we make a call, then we do get a message, right, that the call cannot be made, or the device does not work at the other end. Either we get these two types of messages, or you simply get beep sounds, right, if you do not get any message. So that is what the signaling is, the purpose, the entire module of signaling is in case of telephone networks. Now this is the last diagram that you can see here. This is just the working of the telephone network. So quiescent stage is where nothing is happening. Okay, the start stage, you can say. And from there, when there's a ring, or sorry, not the ring here, this is the from the sender side. So when you want to do a call, you pick up the phone. How do you pick up the phone? You off you off the hook, the phone, off hook the phone. And once that is done, then from the device's side, you have to send a dial tone. Then the dial happens, dialing happens. Once the dialing happens, then the dial string will contain the number to which you want to communicate. So that dial string is collected. That dial string is required for the switch controller, right? So once that is given to the switch controller, then the call setup needs to be done. Once the call setup is complete, then the other side, that the receiver side, there should be a alarm. So that is done by the help of ringing. Okay, so once it rings, then the remote user picks up the phone, and of course then after that the data transmission happens. That means the talking happens. Once the talking is done, then you put down the phone, the receiver puts down the phone, there is a disconnection, and it goes back again to the quiescent stage. Okay, so that is how, this is all we know. But who works in between the most is that the entire switching system. Okay, the switch hardware and the switch controller. Okay, so this is the basic of telephone network here. And with this, we have an end of this class as well as the end of this basics of network systems. I will get to the switch architecture and router architecture in the next class onwards. And there we will get to know about time division, uh, space division multiplexing, and time division multiplexing we have already done anyways. So I think from there onwards we will get to see. But next class onwards, please have your calculators ready, so that if we have any numericals to do, then we can do in the class itself. Okay.